Oh, fancy meeting you here at the Daily Space Weather Videos, a regular feature at the Smash News Network. Let's start out looking at the sun here. A splentacular view of ionized iron. Those are not sunspots, by the way, believe it or not. More on that later. Putting the more on that later. Here's a full disk view in the same wavelength, but also including colorized magnetogram. There is actually a sunspot right here. It's that area there, right there. It's sunspot 2812. No other sunspots, but a series of coronal holes down in this portion are providing some geomagnetic activity right here on planet Earth. We'll also be talking about whether or not that garbage data is really garbage, and more about the coronal hole wind, and indeed some stuff about climate here at the least busted name in news. So it's the worm moon is here, I think, tomorrow. Looks like tomorrow is the worm moon, folks. Send us your lunar photographs if you like. We may feature them on the videos. Here's some more solar imagery. It's sunspot 2812 and an Earth scale for you there. You can see it's remained fairly stable here over the past 24. A little bit of trailing umbrae looking like they want to grow there. Here's a colorized magnetogram of the same region. A non-colorized magnetogram, rather. Great view of the magnetic fields associated with sunspot 2812 and former sunspot 2811, now decayed to plage, not to be confused with a plague. How about 304 angstroms in the same vicinity? It's ionized helium, UV emission spectra. Here's a star chart if you're wondering what's going on above your head, as I usually am. It's in-the-sky.org, where I use my currently southward-facing star chart. If you're up before dawn, you may see Jupiter and Saturn rising ahead of the Sun. Here's some more solar data for you, the radio flux. The 10.7 centimeter radio flux, otherwise known as 2800 megahertz. Currently at 80 solar flux units. Here's the one-year chart of that from Solon.info. They need to update this as it's been around 80. They're about a week behind here on their updates, but that puts it in context anyway, showing you the one-year chart. And you can see how proportional this black line, the radio flux, is to this red line, the sunspot number. So we've got geomagnetic unrest conditions having kicked in late last night. The forecast by NOAA was pretty close here. And you can see geomagnetic unrest and storm conditions predicted for the next approximately 24 hours or so. And it's because of a coronal hole wind stream. We'll talk more about it momentarily. First, let's talk about a volcano live stream as we watch Fagradalsfjall continue to fill up the crater valley as it continues to appear to transform itself into a shield volcano. Other volcanoes erupting include Kadavar, which is northeast of New Guinea, now back on the list. It's exploding and producing a 5,000-foot plume of ash. Cinnabung, 11,000-foot plume of ash above it. Popocatépetl, 18,500 18,500 foot or 18,500 foot ash plume above it in central Mexico as it explodes. Sabancaya in Guatemala both exploding. Sabancaya and Fuego both exploding in Guatemala as I slowly learn to speak English. They're both exploding. They're producing an 11,000 and a 15,000 foot ash plume. It's Pacaya and Fuego. Nevado del Ruiz, volcanic ash not observed. It could be erupting. Don't attempt to pole vault the caldera. Sangre and Reventador, both exploding in Ecuador, producing a 20,000 and 15,000 foot ash plume respectively, and Sabancaya in Peru, also exploding. Seems like a bit of a volcanic uptick. What do you say? Next, looking at seismicity over the past 24 hours. Let's take a look. A string of earthquakes stretching deep into Alaska there, including one of the most recent ones on the list. No major quakes over the past 24. There's a significant one at Italy. Let's check the location of that. Shout out to our European viewers. This one occurred in the Adriatic, pretty much right in the middle of the Adriatic Sea there, but at a large enough magnitude there, likely to be felt even in places like Naples, but especially at Pescara and Split, and especially at Foggia. Continuing on, one deep quake at Fiji at over 483 kilometers. A deep quake in southern Alaska. Largest of the past 24 appears to be this 5.7 near the Izu Islands, near Japan. Here's a quick look at the location of that. Out in the western Pacific. A couple of deep quakes striking at Japan and Peru in the high 4 magnitude range. And continuing on, back to solar data here. Solar flares. Don't get solar flares and coronal mass ejections confused, folks. They're very different things. Solar flares are photons. Coronal mass ejections are primarily protons. Very different animals, we'll say. And let's get back to the spaced out data. And here's the GOES proton flux over the past 3 days. No real surprises there. No spikes in the proton flux. No coronal mass ejections showing up. GOES magnetometer showing this sudden drop, and that is the arrival of the high velocity portion of the coronal hole wind stream, folks. That's reflected in other data that we'll get to momentarily. The sudden drop-off as there's sort of a decrease in the solar wind density followed by an increase in the solar wind speed. First, we're going to look at the polarity of the heliospheric current sheet, shown here in red, the portion that the Earth is in. That's south pole. That's south solar polar field magnetism, folks. And it does look like a green North Pole-oriented current sheet is arriving, perhaps indicating some activity in the southern hemisphere of the sun. We'll keep you posted on that. Here's another view. This is a line-of-sight field plot showing you the sun's B field in blue and coronal holes in red and green. The red one here, moving just out of the Earth-facing region here, is the one providing the current geomagnetic conditions. We've got another North Pole-oriented one moving in. And that one's just starting to stretch down below the equator. So again, watching the solar polar field reversal process. continuing to occur here, and we'll be explaining the mechanism behind that in a later video once we submit a paper for peer review. Here is the animation of both filaments and sunspot groups. You can find this yourself on the Integrated Space Weather Analysis page. It's right on page 1. And you can see there are some filaments here. There are also some filaments that are not shown. It's because they're not seen well because of contrast. There are some filaments in this area as well. And the likelihood of a coronal mass ejection is slightly elevated here. And it's got nothing to do with the sunspot. It just has to do with the filaments and other things that we won't be telling you about because we can't tell you how we forecast coronal mass ejections before they happen on the channel. So here's the KP index, which has gone from 4 all the way back down to 1, and it's expected to jump back up to 5 at any moment, so don't be surprised to see a geomagnetic storm, a G1, where this will be a red bar at the 5 position. And don't be surprised to not see it at the 5 position either, as it is a diffuse coronal hole system, and portions of it could be missing entirely. But in any case, current conditions of global geomagnetism are a KP1. Geomagnetic calm. Next, looking at real-time solar wind. And here's what we're talking about. Just before midnight, we saw the magnetometer drop off, and that coincided with the density drop off. So as the density came down, the velocity came back up. And that geomagnetic unrest condition was right here on the graph, folks. You can also see the uptick in the plasma temperature. At the same moment, the green bar at the bottom, the green line at the bottom. So also shifts in the BTBZ and the phi angle. The phi angle shift happened before this, but the BTBZ jumped all around here during this period of geomagnetic unrest, but has now converged back on the 0 line. So great signature of a weak coronal hole wind stream here. The density only made it up to, I don't even think, 20 protons per cubic centimeter. And then when the density dropped off, the velocity came up, but very weakly, not even making it to 450 kilometers per second for a sustained period. So current conditions are just under 5 protons per cubic centimeter for the density, and for the solar wind speed, 419 kilometers per second. And I think we may have just seen a slight uptick in the density. Oh yeah, okay, I did see that. You're going to see a slight uptick in the density here in the magnetosphere movie. It's 4 hours of data, and you'll see the low-density portion of the plasma get pinned back by some incoming high-density plasma. Toward the end of this, you can see the density increasing there around the Earth. And then it's going to drop back off at the very end, I think. Small reduction there at the end. Keep in mind it shows you high density in blue and low density in white. Next, the pressure. Let me bring that back. So the previous geospace magnetosphere movie was density, just protons per cubic centimeter, folks, and this one is magnetism, magnetohydrodynamic pressure in nanopascals. And let's let that refresh. We are streaming live, and it's not refreshing, so I'm over it. Next, showing ground magnetic perturbations. These are changes to the Earth's B field at the ground level. And these space weather modeling framework, geospace magnetosphere movie models are quite complex. If you want to read about them, head to the Geospace Magnetosphere Movies page, scroll down to details, and click on Space Weather Modeling Framework. It's got a lot of different data sets that are used to obtain this. It is a model, and we show it daily because of the geomagnetic excursion that is commencing. Again, we are streaming live to Twitch right now, folks. It's twitch.tv/smAsho. It's a fantastic mobile streaming platform. And if you're viewing the videos there, don't forget to view them on YouTube. If you're viewing on YouTube, don't forget to check out the Twitch channel and to check out the BitChute channel as well. We're almost at 400 subscribers on BitChute. Will you be our 400th? And let's do a cosmology segment. Now, there are a lot of different topics to talk about when it comes to cosmology. And one of them is what goes on around galactic cores. And that, my friends, my foes and my neutrals, is what goes on around the Milky Way's galactic core. There are a series of very hot, very bright, and very large blue giant stars orbiting the massive radio source at the galactic core known as Sagittarius A star. And that's why I've put it up there, because we're always saying stuff like Milky Way galaxy team for the win. Today's cosmology segment will feature information about garbage data. Now, we've got satellites that look at the Earth, and we've got satellites that look at space, and we've got satellites like the GOES-16, which look at both. One of the missions is the smAsho mission. The smAsho mission is designed to look at radiation coming from Earth, from soil, from the lithosphere, from the oceans, and so on, as the Earth emits radiation, not just the sun. And the smAsho is tasked with measuring said radiation. However, it receives radiation that it doesn't want from the sun, and so it scrubs out that data. Little known fact, that data is actually useful. So it turns out that some microwave frequencies from the sun may be used to forecast things like solar flares. And the forecasting of solar flares is not something we claim to be doing. What we do claim to be doing is explaining the mechanism behind the solar cycles. So 1.4 gigahertz is one of the frequencies, one of the portions of the bandwidth that is relevant, as it is associated with the angular width, speed, and kinetic energy of coronal mass ejections. And you can find this article on phys.org in the Astronomy and Space section, entitled Water Mission, It Takes on Space Weather. So I thought that was an interesting one. What did you think? Leave us a comment and let us know. Today we're not picking anything random at all. Today's Sunday edition of the Daily Space Weather, in the cosmology segment, we're going to talk about an object you may have heard of before. It's Alpha Cygni, or you could call it Cygnus X3, depending on which portion of it you're referring. You could call it Deneb, Alpha Cygni. You could call it the celestial pole star at the other end of the precessional cycle of Earth's axial tilt wobble. You could call it a massive X-ray binary. And here are the transient X-ray outbursts from Cygnus X3. And without further explanation of that, let's go to a visual. What's interesting about Cygnus X3 is that the massive radio source known as Cygnus X3 is believed to be something like a neutron star, a black hole, a quark star. We've got all kinds of crazy ideas about what this thing is. But in any case, this object right here is orbiting a massive Wolf-Rayet star. And what we're seeing when we look at Deneb is actually one point of light. And it's because the Earth and Sun are located inside of this poloidal field jet. So this object is located somewhere between 3,000 and 18,000 light years. The distance is hotly contested, as it's difficult to measure the distance of an object with a jet directed directly toward you. And what's interesting about this is that, well, we've got this cloud of ionized gas and dust, which is produced by the interaction between this more massive object and this apparently less massive but much larger object, which also happens to be a Wolf-Rayet star. This object here, the Wolf-Rayet star, is so massive, if it were in our solar system, you'd be inside of it. It's approximately the size of Mars's orbit, and this more massive object completes this orbit in, wait for it, 4.8 hours, which means this massive object is actually traveling at relativistic speeds, and it is sending protons all the way to the surface of the planet and indeed into the planet. Or at least we're seeing neutrons there. So in all likelihood, we're seeing protons there. But in any case, without getting further into what's going on with Cygnus X3, I'd invite everybody to check out our forum, smAsho.com/forum. In the cosmology section, there's a whole forum on cosmology. We've recently updated the most. Now, while there is a forum topic entirely about Cygnus X3 massive X-ray binary, we've got another forum topic known as the most. And we've updated the articles that we covered yesterday, so check that out if you haven't. Is the nearest star cluster located 153 light years away only? The Hyades cluster? Is it being torn apart? Or is it exploding? Or is it doing a combination of both? Also, we talked about the Huygens Nebula yesterday, the Huygens supernoval remnant. And so that's today's cosmology segment. And I've been your host, Dan, a.k.a. smAsho. Don't forget to press like and subscribe if you enjoy the content. And let's continue on to talk about more interesting features of space, like the electron flux. Here's a one-year chart of it as reported by Solon.info. And the electron flux is in a fairly moderate range here. Expect to see this crater, especially if we see stronger coronal hole windstream pulses. If not, it might stay in a more moderate range. It's too tough to really forecast this at the moment. But there's the NOAA forecast. The green boxes are the forecast, and the yellow diamonds are not Lucky Charms marshmallows. Those are the observations. Here's just a diagram showing you the location of things like satellites. And I would remind our viewers that geosynchronous satellites are at like 20 to 40,000 miles of altitude. And the International Space Station located there at 230 miles. This is NASA's graphic, by the way. I didn't create this graphic. That's NASA's graphic. And what we're showing you here is the total electron content. Essentially, the air column through the Van Allen belt. And we show this daily to show the locations of GPS errors, but more importantly, to show the physics of where electrons are located. And they trail the sun slightly at their location. You'll see the most GPS errors around noon at the equator. And if you want to look at it yourself, it's the total electron content forecast. Here's another diagram of the atmosphere. This one showing you a smaller portion of the geospace. And we always show this one because the next imagery we'll show is for 300 kilometers, the location of the ionosphere. And here's a visualization of that. It looks like we have some measuring errors around the prime meridian. I think that has to do with date stamping. You can see some anomalies there actually happening as well. Some sudden charge ups and charge downs over places like South America. Keep in mind, folks, the weakest part of the magnetosphere is around here at the South Atlantic anomaly and also down here at the South African anomaly. And that really does affect the way this ionospheric data looks, as well as the electron content for those areas. So some interesting anomalies shown there. And I'll just give this a minute to play all the way through. Here's a latest image from 10:15 Universal Time. Looking a little charged up in the southern hemisphere there, but not particularly abnormal. Next, a little bit about the GOES-16, as many of the data sets that we use are derived from the GOES-16. And the GOES 16 is at about 36,000 kilometers of altitude. And it's got instruments that are Earth-facing and instruments that are Sun-facing. So it's looking at 6 different wavelengths in the UV spectrum, as well as in X-ray. And then it's got the Advanced Baseline Imager, which is complex, and the Geostationary Lightning Mapper. So that's where the GOES 16 data is derived. Apogee altitude is 35,793 kilometers, and perigee altitude is 35,780 kilometers. So a very circular orbit there, the GOES 16. And that baseline imager, advanced baseline imager, the ABI, is a very complex instrument. It's using things like radiometers. It also has magnetometers. So the GOES 16 is doing a lot of jobs. And just a little tidbit on that. If you want to read more about that, that's the Wikipedia article. And let's do some meteorology stuff and some climate. We've got a great article that just refutes itself and makes zero sense. I'll just read a tidbit from it. But here are the jet streams of the Western world. Quite chaotic jet streams here in the both hemispheres, really. Check out the extreme bends here over southern South America. A total S-shaped, that must stand for smAsho mash. And here are the jets of the eastern world. Quite chaotic there as well. Chaotic jet streams right now, folks. Quick look at surface winds. A very large low pressure system there to the southwest of Australia. Here are surface winds of the west. Strong winds over the North Atlantic as well as the South Atlantic. Check out this article. Zealandia switch may be missing link in understanding Ice Age climates. So I don't know what the suggestion is here. It's a suggestion that we're not currently in an ice age. An ice age is defined as when a planet has both poles covered by ice all year round. What's going on Earth right now? Are the poles currently melted? I'm pretty sure both poles are covered in ice all year round, but let's just give it a chance. The origins of Ice Age climates may lie in the southern hemisphere, where interactions among the westerly wind system, the Southern Ocean, and tropical Pacific can trigger rapid global changes in atmospheric temperature, according to an international research team led by University of Maine. Okay. I'm just going to let the article scroll here and then skip to the bottom because I don't really want to spend too much time on this. But check out this idea at the bottom. You're going to love this. The southward shift of the southern hemisphere westerlies at the termination of the last ice age was accompanied by a gradual but sustained release of carbon dioxide from the Southern Ocean, which may have helped to lock the climate system into a warm interglacial mode. The researchers suggest that the introduction of fossil carbon dioxide into the atmosphere may be reawakening the same dynamics that ended the last ice age, potentially propelling the climate system into a new mode. Anyway. Yeah. Anyway, I just have one other thing to say. Carbon dioxide is not a pollutant, does not control Earth's climate, should not be scrubbed from the atmosphere, and is the most important trace gas by far on the planet, in that it is at the base of every food chain. Next, looking at pressure cells here on windy.com. And check out the double low pressure system there in the North Atlantic, kicking up some heavy surface winds. I wouldn't want to be a Viking attempting to go from Greenland to Iceland right now. It would be a mess. Look at the pressure gradients. And when you see lines that tightly packed, especially next to a low pressure system, those are some severe pressure gradients. Let's advance this into tomorrow. We're going to show the GFS forecast today for a change. Here's the GFS forecast for pressure at 12 noon Eastern time tomorrow. An interesting swing of pressure. It's going to create some variable weather over the United States in the coming days. How about a real-time lightning map? I like to use lightningmaps.org. We showed some pretty intense lightning yesterday, and we've got some today as well, right in the same location. It looks like it's going to miss you this time, Nashville. Also some lightning here west of Richmond. Anyway, here's the world lightning map. And as we approach the solstice, you can see these lines slanting toward the north, an indication that the world is indeed flat. Continuing on to show some more meteorological stuff, and look at the concentration of storms there, an extremely concentrated line of storms, and it's going to cause some training, which is when the storms are moving parallel with their line of propagation. So that's going to cause some sustained storms in some certain areas. Fortunately, it is moving a little bit to the east. So heavy storms there and some snow falling in places like Wisconsin and the northern peninsula. Lake Superior seeing some heavy snow falling on its eastern portion. Here's the cloud layer. Here's the water vapor cloud layer. Water vapor. It's an atmospheric river, folks. Oh my God. Make sure you have your kayak ready. Make sure you have your hard hat on. Get in a bunker, but make sure the bunker is properly drained, because if the bunker fills with water, you want to get back out of the bunker. Maybe be in the bunker in your kayak with a hard hat on or something like that. Maybe a motorcycle helmet. I don't know. Maybe a whitewater rafting helmet, or maybe a kayaking specific helmet. Maybe wear 2 helmets just to be extra safe. And if you wear a mask too and get vaccinated and locked down and wear a mask and a helmet and hide in a bunker, or perhaps build a ranch in Colorado, we can all be safe forever and ever and ever and ever and ever and ever. And at the Smash News Network, we want you to be safe. That's why we're the least busted name in news. Let's take a look at some of the most current solar imagery we can. How about some less than 2-minute-old data from Udaipur, India. Yes, Udaipur, India. Oh my God, it must be Nibiru moving in between the sun and the telescope. Check it out, watch. Right at the beginning, oh my God, Nibiru. It was a solar eclipse caused by Nibiru, folks. There must be a planet in between the sun and the earth. It's got to be a thing. And thanks for everybody leaving ridiculous comments. Just kidding, folks. I don't think anybody has argued the existence of Nibiru for a while. And let me invite all of our viewers to our April Poetry Slam. We're going to have a Poetry Slam. If you're not familiar with what it is, read up about our April Slam Poetry Contest at smashamash.com/forum. And perhaps you'll win a free month at the $3 intro Patreon tier. Read all about that. If you're not familiar with slam poetry, we put some little links and so on about that. You'll have to create an account at smashamash.com/forum, and you'll have to post your slam poetry on our forum. So for the month of April, we'll be doing a slam poetry contest. Read all about it at the forums. Thanks to our patrons, the true source of funding for the content, as we make just this side of zilch on YouTube. Please tell your friends, foes, science noobs, and science pros about the channel, or perhaps consider becoming a patron. Thanks, Smash Team. Everybody who watches the videos, leaves comments, etc. We consider it a collaborative effort, and we don't consider any stupid people or hacks or frauds our competition. We forgive, we don't forget, we hold accountable, and we are Legion. The Smash Team. So welcome to the Neo-Renaissance, folks. Check out our own website as well. Today's featured product is available at the Smash Store. So if you click on this link from our homepage, the Smash Store link, it'll redirect you to this Teespring shop, which is largely astronomy themed. We've got the Condensed Matter Matters shirt. We've got the Deneb shirt. We've got the Cygnus A shirt. Also another Condensed Matter shirt. This one's printed on both sides, and it's got sleeve prints. But today's featured product is the Smash Team shirt. And one of the ways to join the Smash Team is to support the channel by buying merch. Let's take a look at the latest image here in ultra-high resolution colorized magnetogram. Pretty organized is this plage, but we've only got one sunspot last I checked. And there is the most current image. Here's some more solar imagery for you to close things out. It's the 304 angstroms ionized helium full disk. Here is 193 angstroms. And those coronal holes just south of the solar equator there are the ones that have sent some protons our way, as well as some other elements, undoubtedly. And here's a close-up of that, as well as the south solar polar field region, where a coronal hole remains. So thanks for tuning in, folks. Remember, stare at the sun, attempt to understand the physics, don't drink, and if you do, don't drive. Seriously, don't drive. What fun is that? And welcome to the Neo-Renaissance. Visit our links. Enter our Poetry Slam contest. It starts on April 1st. Don't be April Fools. Enter the contest. Win a free month of Patreon, perhaps. Third judge to be announced. And since it'll never be now again, may that solar wind be at your back.